Hello, everyone. Okay, so we are going to do now dividing rationals. Okay, so here's what I need you guys to do is go and start writing this down in your notes. Now, with dividing rationals, it's actually the exact same thing as multiplying. There's just one extra step beforehand. The one step beforehand is that we actually will flip the second fraction and change the division sign into multiplication. That is it. After that, you do the exact same thing. We're going to factor every numerator and denominator that we can. Remember, don't forget to ask yourself if there's a greatest common factor. Divide out any factors common to both. So we want to make sure our answer is in that simplified form, so no common factors other than one, and then we'll leave our answers in that factored form. So go ahead, if you still have not gotten all this down, pause the video and write all this information down. Okay, let's go ahead. We're going to try our first example. Now, with these divisions, we are not going to find the restrictions. You won't have that on your homework as well. So it says simplify the rational expression. So let's start with example 1. So the very first thing is we keep the first fraction the same. We change the division into multiplication, and then we're going to flip this second fraction. So we now have 7x over 2x minus 10 times, now we'll have x squared minus 11x plus 30 over x squared minus 6x. Okay, here's what I need you guys to do. I want you to pause the video and then factor any numerators or denominators that you can. Okay, here's what you should have gotten. So really both denominators had a greatest common factor. The first one, even though it's linear, it does have a 2, so we got to take that out. And the other one had an x. Okay, so now I'm going to go ahead and cancel anything I see in the numerator and denominator. Actually, let me have you guys do that because this is good practice. So go ahead, pause the video, cancel things out to get to your final answer. So go ahead and do that for me. Okay, so we can cancel out the x minus 5s, the x minus 6s, which I just realized right here I put plus 6 there, but I'm going to erase that to put a minus because that's what it should be. Sorry for the mistake there. Now, some of you may have not noticed there is now an x in the numerator and denominator because what's left over is 7x and then 2x. This is where we can cancel out the x's because they are being multiplied by coefficients. So now we're just left with 7/2, and that's our final answer. Okay, let's look at example 2. Now, just like we did in our multiplication, anytime you have something that is not a fraction, put it over 1 to create it as a fraction. Okay, here's what I want you guys to do. Go ahead and pause the video and then do that keep, change, flip. Here's what you should get. Now, I want you guys to once again pause the video and then factor anything you can. So go ahead and do that for me. Okay, here's what you should have gotten. Okay, so let's kind of go back over how we factor this really quickly. This is when you have an a value other than 1. So when we have the 6x squared plus x minus 15, remember, not only do we need to find numbers that multiply to 15 here, but also to 6. And this is where you may just have to use your, we use the check and guess method here. So I'm going to try 2x and 3x. And our goal, once again, is to try to combine to a positive one in the middle. And I'll try 3 and 5 here. So I multiply the inner, that gives me 9x. I multiply the outer. If I think about 9x and 10x, can they, if I add or subtract them, give me x? Yes. To get a positive x, that means my 9 has to be negative. So that means I need to have a minus, so 2x minus 3, and a 3x plus 5. Okay. Okay, so that's how I got that one. And in the denominator, it had a greatest common factor of x. Remember, I divide each term by x to get my final answer here. Okay, now I want you guys to once again pause the video and go ahead and cancel things out. Okay, here's what we should have gotten. So we just cancel out, the only thing is the 3x plus 5s. And in the numerator, I'm just left with 2x minus 3. I do go ahead and multiply my 4x squared and x. The reason being it is just a monomial. So if you have monomials, you're multiplying and it stays a monomial, that is fine to multiply. We just don't want something, and this is just an example, like let's say we had x plus 3 in the top, and then we had x minus 1, right? I'm not going to multiply this out because I want to keep it in factored form. But that's when I have like something more than a monomial, okay? Okay, let's go ahead. Let's look at number 3. Actually, here's what I would like you guys to do. Go ahead and pause the video and try this entire one on your own. So go ahead and do that. Okay, here's what you should have gotten. So this one, I keep both. So first of all, I changed 3x minus 5. I made that into a fraction by putting it over 1. Now, we do have division. Remember, you're going to keep all of the fractions before it exactly the same. We changed the division to multiplication, and then we flipped the very last fraction here. Then I factored. The only thing I could factor was 9x squared plus 25. That factors out to 3x minus 5 and 3x plus 5. Remember, that's your difference of squares. Then I cancel things out. Anything I see in the numerator and in the denominator, you do it. Even if it's not in the same fraction, that is okay. So x plus 5, so there's one in the numerator, one in the denominator, cancel. 3x minus 5, one in the numerator, one in the denominator, cancel. Now, what I'm left with is x in the numerator and then 3x plus 5. And remember, because there's this plus, I cannot just cancel out my x's here, okay? If this was all just basically being multiplied, then I could, but otherwise, this would be my final answer. Okay, if you have any questions about multiplying or dividing or both with rational expressions, you can always contact me. So either email me or if you need a Google Meet link, just let me know and I can email you with that. Okay, see you guys later.